Hi guys, welcome to the video. Hope you're all doing well. This is part 3 of the DevWing Foam video tutorial series. I'll put a link up to a playlist if you missed parts 1 and 2. So in parts 1 we covered the design. Parts 2 we covered the creating the cutting projects. And now in this part here we'll actually make the foam parts. So I'm going to start off with how to set the foam cutter up, because I get quite a few questions from the website and also from the YouTube comments about how to set the foam cutter up, what spring tension do I use, what's the carriage distances, and what do I use to power the wire. So I'm going to cover them in the first part of the video, so we've got the thing set up correctly, so we could stand the best chance of getting a good wing out. So then we'll move on to actually cutting the parts out. So I've already cut out the middle section. I didn't think that was worth filming because it's a fairly straightforward section, that, but I will show you the results of that. Then we'll go on to cut the transition sections out, where we're going from a Clark Y to an M860 profile to lead us onto our main wing, and then we'll go on to actually cutting out the main wings. And it went reasonably well. I had a few little issues which I'll show you in the video, mainly to do with temperature, but I'll explain them as we go along. And then in the last part of the video, what I'm going to do is show you how to cut the root and tip angles. Because in the video, what we did, we used the option to rotate the wing to align the trailing edge with the hot wire. And the reason for doing that is two reasons. One, it saves a lot on foam. But if you've got a really swept back wing, you might not have enough travel on your foam cutter to actually get the wing out. But by using this option, we can get highly swept back wings, and it also saves a lot of foam. And I've managed to get, a whole set of wings out of one piece of foam. And then at the final part, I'll put all the parts together and show you what we've got. So without further ado, let's get started. So before we start the foam cutting, what we need to do is get the foam cutter set up. And I get a few questions on the website and on YouTube about certain aspects of it. So I thought I'd just cover some of them with you. So it will probably make things a little bit easier, because if you're first starting out in this, it can be a little bit daunting sometimes. So let's go over a few of the things. So in part 2, we created the G code. In the setup, we told the system how much travel we've got on our machine. So we gave it distances for the horizontal and the vertical, and the distance of the carriages. So these two are quite easy to work out. So all you need to do is in the control software that you're using. So at the moment I'm using CNC Foam for this, but it works on any of the other software. And all you need to do is just run the system until it comes to sort of the end of its travel as far as it can go, and then note down the figures that you've got. So within this here, I've got about 550 on the horizontal and about 300 on the vertical. But one of the most common questions I get is, where do you measure the distance from the two carriages? Because that's one of the, for straight wings it's not that important, but when you're doing tapered wings, it can make a difference, because if you haven't got that right and you've got the foam to one side or the other, the wing will come out the wrong size. Trust me, I know, I've done it. So the way I work it out is that where the actual wire connects and pivots from, so I'll just move this camera a bit close. So I've got my wire pivoting from these two eyelets that you can see there. And what I do is I measure the distance from where the wire actually pivots. So on here I've got about 790. So that's the actual distance I work with, and it seems to work out accurately. So with DevWing Foam and Profili, there's options to print out the profiles. So I've done that in the past and printed the profiles out and then laid the parts over the top. And to the naked eye, they look perfect. Yeah, so what I also do as well is I screw the machine down. So luckily this bench is quite solid where it's on. So I've got it screwed down, and I make sure it's square as well. So all I do is put the square on there and just make sure it's square on both of them. And the other thing you'll need to do as well is make sure that they're the same depth as well. So this one's not out further than that one. And then You can line your wire up against the foam before we start cutting, but it's nice to get it all squared and set up before you start doing any foam cutting. And then what I do then is find the midpoint, because in DevWing Foam all the placement of the foam is done via the centre. You can do it one way or the other, but I tend to like to work to the centre. And then what I do is I put the foam on and then measure from this edge, which is a little bit tricky. I use a square and a tape measure and mark on the foam the exact centre point of the foam. And the other thing I get questions on quite a lot as well is tension in the spring. Now, so what I've done is I've actually taken the spring off of here. When I had it out in the shed, I had a lot more distance, so I could actually put the spring down here, but because I'm a little bit restricted in width in here, what I've actually done is moved the spring up to there, and it's attached to the wire. There's a little joining piece there, and this is very strong fishing wire. I think it's about 60 pound or something like that. And so what happens now, as I pull, you see as I pull on the wire, it just tensions the string. And it means if I had the spring down here, I would be losing quite a lot of width there. And so it would restrict the length of the spring. And sometimes when you're doing these tapered wings, you do get a lot of movement on it. So and so that seems to work quite well there. So I've anchored the fishing line to the bolts here that are holding this piece to the, and that seems to work quite well. Another thing that comes up quite a lot as well is how to power the wire. Now, there's a couple of ways you can do it. On the ramps board that we're using here, so this works on CNC foam and also the one that's on the website, 4-axis garble port. And you use what would normally power the heated bed, and it uses a PWM signal, so pulse width modulation, I think. And I have used it, and it does work, but what I've found with it, it's not very consistent. On smaller pieces, it seems to be fine. So what I've used, and I've used since the beginning, I've used my iCharge. Now you don't necessarily have to use an iCharger. Most LiPo battery chargers will work. And what you can do, you can set them on an DevCad setting and roughly start around about 2 amps, see how that works. Now on the iCharge, it has got a special foam cut option. So I'll just switch it on. So on the iCharge, it has this foam cut option. So I think really all it is just it's probably very similar to the DevCad option. So I've got that set for 2.3 amps. The voltage doesn't seem to matter too much, because what happens is as you connect the wire up, and if I start the charger going, so it doesn't actually start the charger, I've still got to run it manually. And what you can see is the amperage is gradually coming up, and the voltage is altering all the time. So what I do then is just let it come up to amperage. So we're running about 2.3 amps on this, and then normally what I do is I just run a quick test to see, and you can see that's going through quite easily there. So it does vary from the type of foam. So on this XPS foam, on this XPS pink foam, which is a bit like blue foam, I think I use 2.7 amps on that. So I keep a record of what foam I use and the amperage, and also the length makes a difference. So if you bring this closer in and you're running 2.3 amps, it's obviously going to get hotter. You don't want the wire glowing red, because it'll be much too hot and you'll probably melt away most of your foam. But it just needs to be hot enough to cut through the foam easily. And when you watch the cut going, if you see the wire dragging, it means that the wire's not hot enough, or you've got the speed too fast. I tend to leave the speed alone and just adjust the current. And then what I can do within CNC Foam, I'll just bring the camera down here so you can see so I've got the laptop down here because I've got no room for it up there. So all I'll do there, you can see it's got the hot wire option there. Turn it off. And in settings, we've got hot wire management. And then we've got different options there. So we can use it as a PWM signal. And it does work, but I prefer to use with the charger. So that's it basically in setting up the foam cutter. So what we'll do now is we'll go on to actually cutting some wing cores. So I've already cut the centre section, and I've used some XPS foam for this. And this is fairly easy to do, so I didn't want to waste too much time showing how to cut this. But you can see it's got the lightning holes in, and then it's got the spars underneath there, and the spars are so the spars are going in some 4mm spars, and they fit just about right in there. So what will happen then is we'll get them glued in, and then put some thin bolster over there, and then or even a little bit of foam, and that will fill that in. And so all I've done there, where it's gone in for the lightning holes, all I've done there, it's gone for lightning holes, is I've put some bolster strip in there. So probably what I'm going to do is later on, when the wing's built, is cut the little access holes out here. You can see another line there because I didn't have quite enough foam to do this, so I've had to glue two pieces together. But we should be okay with that. So we'll go on to do the transition sections next. So I've already got a piece cut ready to do that. So this is the piece we're going to use. And I'm actually going to cut both of them at once because it's a smallish section. And I've done a bit of testing. As you can see on this scrap foam, I've done a bit of testing on there, and we can get both out of in one go. So that's what we'll go on to next. We'll set this foam up and then run the cut and see how it goes. Fingers crossed. Right, so we're ready to do the first cut. So this transition piece, I'm going to do both pieces together. And what I've done, this is the foam I'm using. This is it's actually sort of blacky grey in colour. And I've just done a couple of tests on it to check the wire temperature. It looks okay, but we'll find out in a minute. And what I've done is I've put some tape on the top of the foam piece, marked the centre, and I've centred it up by using these rules in the middle there, just to make sure it's centred. And all this battery there is holding this support piece, and the actual foam block is on some double-sided tape. So what we'll do is we'll start up DevWing Foam and then send the G-code. So I'm going to be using DevCNC Foam for this. I decided to purchase a license for it because it supports G93, which is what's recommended for DevWing Foam, and it also supports limit switches. I'm going to do a full tutorial on DevCNC Foam, but I won't go into it too much now because it'll make the video too long. Right, DevWing Foam's going. And we'll switch on the controller. So the actual motors are locked now. So I've got the computer, you probably can't see it, but the computer's down below because I haven't got room on the table. So as you can see there, we're going to be doing two. So you should be able to see a screenshot of this. And I've been through and checked all the curve values and settings. And it's given us our foam size there. So this bit of foam is actually a little bit bigger. And then that's if we want to pre-cut the block, which I've cut that manually. And if we just have a look at the placement, so it gives us our foam size, and then it gives us the offset. So what I've had to do is lift the foam support block up a few millimeters so it's saying 36 on here. So it's because the transition piece has got different profiles, and so you'll see that the carriages, the vertical ones, will go up different heights. So what we'll do now, if we go to, we've got Dev CNC Foam selected, and it says create the right G code and run the selected application. So that should start Dev CNC Foam up for us. There we go. I'll just take the side profiles off for a minute. And I've got the hot wire actually getting its power from the ramps board. So it's just an on and off. So it just supplies power to the wire. So I don't know where you can see it, but the actual foam cut options come on now. And so what I'll do is I'll set that to on by pressing start. And what I do then is wait until it comes up to 2.7 amps, which I've got it set to. Have a slurp of tea while we're doing that. So there we are, 2.6, 2.7. Just double check that it's hot. Yeah, straight through. And then what we do then, the G code's in there, so it's just a matter of selecting start now. Hopefully, if I've got everything right, it should work. The only thing to watch out for is make sure your wires don't touch the hot wire that are feeding the hot wire. So as it's doing 2, it's going to be coming up and doing the top one first. So I'll speed some of this section up because it's not that exciting to watch. Just have a look, see what we've got here. Yeah. So this is the transition section that we're cutting. I actually modified the design a little bit to use the actual thickness of the foam to make it a little bit easier. So this foam is 50 millimeters thick, and I think originally I got them set to 40 millimeters, so I've just expanded them a little bit. So you can see now that the axis over nearest the window is going up, and then this one's coming down. So it looks to be going okay. One of the things to check for is to make sure the wire isn't dragging. So I usually just go and stand and look above it to make sure it looks straight. Because if it's dragging, it means that you've either got the speed too fast or not enough current. So it looks to be going through okay. So a little bit further it'll be doing the spar hole. It's usually at the maximum thickness, which it's coming up to now. So it goes down first and then goes up to make a nice clean cut. So first one done. Now it should go down to do the one underneath. You always want to do the top one first, because if you did the bottom one, what tends to happen, it tends to drop a little bit of foam. And you'd probably lose stability as well. So now we're doing the opposite. So we're doing the left and right here. That's it. Right, so I'll switch the wire off. The wire's gone off. See what we've got. There's one. There's the other. See how it matches up with this. It's not bad at all. So that way you can see. So there's our spar holes lining up. This one's a little bit, these bits of bolts are sticking out, that's why it's not lining up exactly. Yeah, so that's not bad at all. At the back end here, I'm going to be cutting some of this away as well for the motor mount to go in. So yeah, so that looks okay. Just got the two outer sections to do now. Yes, I'm quite pleased with that. Right, so what we'll do now is we'll go on to do the outer sections. Right, so I've set it up ready to do the outer section, and because it's a bit bigger piece, I've put a couple of little sockets on there just to stop it moving. It's got some double-sided tape underneath as well. So we'll set it going. Just wait till it comes up to 2.7 amps. Right. Hopefully it should work. So with this one, we've got an aileron in with it. So let's just turn it on its side again. Not that one. That one. Maybe better to look at it that way this time. Just have a look at the wire, see if the wire looks straight. Yeah. There we are, done. quicker than I thought. Right, let's switch the wire off. This is the first time I've really used this foam. So, yeah, as you can probably see there, it just came out the top a little bit, just there, but I think we can get around that with some filling. It's not like a major section. So, let's have a look. Yeah, I think if anything, the temperature, the wire's a little bit hot. So, yeah, you can see it's melted a little bit there. As it's got down towards the end, it's melted more because it's not moving as far. Right, guys, I wasn't very happy with the cores that came out, and I had got a bit of an error on the setup. So I'd got the set too high in the foam. So I went in and altered that, and I've already run one cut, and it's come out all right. But what I've also done, I've also lowered the current down. So instead of having 2.7 amps, I've gone to 2.3 amps. And if I remember when I was cutting foam before, that's what I used to use on my iCharger. And as I said before, you can use a normal LiPo charger if you've got a NiCad setting on there and set it to, you know, roughly about 2 amps and then sort of work up from there. So I've cut one out already and it looks a lot better, but what we'll do is we'll take this one out now and see what she looks like. So you can see the difference. So you can see the differences on the root and the tip. How much is, because we've got different kerf values for the root and tip. So hopefully that gives us a wing that's good size. So let's take this out. So that's come out there, and it's still left the aileron section in. So if we have a look, yeah, and that's where the real difference is. So yeah, a little bit tight there. So if we look at that spar now, that looks a lot better in there now. So what I'll do is I'll swing the camera around and we'll have a look at the foam cores and show you what the differences are. Right, so I've laid these cores out as they've been cut. So this was the first one, second one, and then the third and the fourth. Well, that might have been third and fourth cut. But this one we started off at 2.7 amps on the iCharger. And I think, as you can see down there, when we get towards the tip, it's melted quite a lot away there. And it's even, if we look on the edge there, you can see that on the edge there, it's even melted some in there and curved it away. So it'd still be usable, you know, with a little bit of a filling and that it would be probably okay. And then, so that was 2.7 amps. Then I turned this one down to 2.5, I think, and then altered the kerf values a bit. And it's still got a slight indentation there, as you can see, but it does look better if we compare the two now. You can see the differences in the end of the spar holes. So that one's getting better. And luckily with this foam, so with DevWing Foam, because you can rotate the wing and align it with the trailing edge, you save a lot of foam. So you can see on this section here, I've managed to get two wings out there. So just by turning it and rotating it. So if we hadn't have done that, so if we'd have cut it like that, we'd have probably only got one wing core out of this piece of foam. So it is a good option. Now the only thing we've got to do now is we've now got to cut the angles on the root and tip, but we'll go into that in a little bit and I'll show you how I do that. So if we now look at these, so if we now look at the tip on both of them, you can see there's a big difference. There's still a little bit there, but as I said, it's always a little bit of a compromise to get it spot on, but that's good enough there. And the actual carbon rod, so this is 4mm carbon rod, so the 4mm carbon rod fits in there quite well, a little bit snug at the top and fits quite well down there, so I think that's going to be absolutely fine. That, so once I did that, I then did the second one, and that's nice and snug at the top, and so that's just about the right settings for this foam. So as I said previously, with foam cutting, there's a lot of testing going on, and you can probably see all the scrap bits I've used earlier. So what you need to do is run quite a few tests, and you will ruin some foam. I mean, I've ruined some cut jobs that I thought were going to be okay, with, you know, something's gone wrong. So that's why I tend to use this foam now. And what we'll be doing with the carbon rods will be going in, and then I'll be covering them in my favourite method of brown paper and PVA, and then make an incredibly strong wing. So what we'll do now is I'll show you how I cut the root and tip. So we've got the wing cores cut now, but because we've used the option to rotate the wing to align with the trailing edge to save on foam, what we need to do now is cut the root and tip. Now, I've already cut one, so this is what we need to get to, and this is the opposite wing. So you can see that, you know, there's a big difference there. And so this hasn't got the root and tip cut to the correct angles yet. So the way I do it is I mark the angles and then take it over to the foam cutter and then line it up with the foam cutter on these lines that I've created, and we'll go into show you how you create them in a moment, and then set the foam cutter to go straight down. I'll show you that bit as we come to it. So the first thing we need to do is get these angles correctly marked on the core. Now the way to do it, so we'll just move this one out of the way that's already been done. So here's the wing core with this part's called the shell, that what it's come out of. And all I've done is I've just made it a bit smaller and just cut it and then split it in half. So we can split it in half like that. So we've got the top piece and then we've got the bottom piece as well. And we've still got the aileron in there as well. So don't throw these away, because these are really handy when we're building. So we can keep the core supported in these shells, and they don't get damaged, because with it being soft foam at the moment, it can get damaged quite easily. So the first thing we need to do before we do anything is we'll just take the core out. And what we need to do is we need to mark these angles, and then we'll take it across to the foam cutter, and we'll use the Y just to go down and chop these angles correctly. But what we need to do is get these angles marked correctly first of all. And the way I do it, we take the core that we want to mark the angle on, and what I do is I create a full-size template of the wing. So I've used this is actually a lining paper for putting on walls. I've got a whole roll of it here. Next door neighbour gave this to me. He had some decorating done, he had this left over. He said, did you want it? And I thought, this would be dead handy for this type of thing. So what I've done is I've just taken a piece off and I've marked the actual dimensions out on here. So what I do is I start off by getting the span first. So I'll mark a line there and then measure across for the wingspan, which is 365. Mark that down there. And you've got to make sure the paper's big enough to be able to do this. And then start marking the sweep back and the tip, and then just join the lines up. So this is what the size our wing should be with the aileron attached as well. And then what I do then, I think I've actually got I've got it on both sides actually. Yeah, So it's exactly the same on this side. Just put that down there to stop it from rolling. And then all I do then is put the wing on, and to make sure I'm right on this edge properly, I use this piece of angle here. So I just line that up exactly on the line there, push what we can do as well is just put a bit of weight on there to stop that from moving. And then let's pull this over a bit so you can see it a bit better. Hopefully that will line up properly. And then what I do then, that's a little bit off there, bring the wing along and then just look down it until the root, edge of the root there is just in line, and then mark it. So there's a couple of ways to do this. I've got this white marker pen here, which seems to work quite well on here once you get it going. And so all I do to start with, you don't need to mark it all the way across, we just need enough to line the wire up. So what I tend to do is make sure it's got a good portion there. Then mark that. So we've got that there. And then transfer that to there so it doesn't move. And then we can move that out of the way then, and we do the same up the top then. And it helps with being a flexible rule as well, so we can just line it up there. And then what we'll do, we'll put it in the foam cutter in the bottom piece, and that keeps it nice and square. And then I've got a little bit of G-code we just run to chop that down. So we do the same on the tip here. Tip's a little bit easier. Let's just move it up a little bit. Still looking in line there yet, because it's not quite as big. And then not the best of pens, this. There we go. Right, so we've got them marks on there now, and we can also, we don't necessarily have to mark it on the aileron, because what we'll do now, we can actually pin the core into the shell so it doesn't move. So we get the bottom part. And just put it in there, and then I just get a couple of pins. Just make sure we're lined. And the pins are just to stop it moving within the foam, so I just put them through at a bit of an angle. And then we'll do the same on the aileron section. And then what we'll do now, we'll take it over to the foam cutter, set the foam cutter up, and then we'll just run the wire straight through there, and that will give us our angle. Then it's up about 55mm, and then I brought the carriages forward about 120mm. And then what we do then, we bring our wing core across in the shell with it pinned in so it doesn't move. And basically all we're going to do is just line that line up across there. So Let's just, and then set the wire up. Right, so I think what I'm going to do, I'm just going to bring the wire down a little bit because it looks a little bit high there, so I can get a better view of it. So what we'll do is we'll come down to, let's try 45. Oh, did the wrong one then. How's that looking there? Yeah, it's not too bad. So all I do now is look down over the top of it. That's looking about, take the glasses off. The light's not the best here. Yeah, that's looking pretty good there. And then what we need to do is set the wire going. So I'll connect. And then we're still on 2.3. So we'll let that come up to temperature. Point 2.3. Let's just check it, make sure it is. Yeah, that's okay. And all I do then is run this little piece of G code. So the first two lines, G21 and G17 and G90, are just setting the foam cutter up in metric, and I think it's a plane, and then in absolute mode. I could be wrong on that. And then all we'll do is run the G code now. So the first line, G01, that's got the feed on, so that's going to feed it down at the correct rate. And then when it's done, G00 back up to X120, U120, Y55, and V55. That's going to bring it back out. So here we go. And by having it in the shell, it makes sure that the core is actually straight, so you're not going to get any extra dihedral or anhedral added onto the tip. And then once it's done that, it'll come back out. So it's cut a little bit of aeroplane there as well. Let's get a little bit of aeroplane off there. So that looks pretty good. So we'll just turn the wire off. And then all we do, turn it round and do exactly the same on the tip. So I'll bring the wire down a bit because it's a little bit high there for lining up. So I think we'll come down to about 40 on there. And one of the beauties of DevCNC foam is you can synchronise on the jog here. You can synchronise so it keeps jogs moves linked. So I only have to tell it to move on the vertical axis, and it does both the left and right. So we'll go to, let's try 35, see where that gets us. Oh yeah, just about spot on there. So let's get our weight on again, just to keep it straight. A bit near that end. Yep, that looks right there. switch the wire back on. 2.3. Wait for that to come up to temperature. There we go. And then all we do is rewind the G-code. So you can see the red dot's back at the top there. And then we're up to temperature, so we'll press start again. There we go, and it's just pulled the tip piece off. Let's take that off. Mind your fingers. Stop the wire. We can switch DevWing Foam off now. Right, so we'll have a look at the, we'll pull our pins out. Let's get the other side. So here we've got our two cores now. Hopefully they should be more or less the same. Yeah, make a nice little wing that. So there we are, guys. That's all the parts cut. So we've got our outer, transition, middle piece, transition, outer, and then we've got an ailerons there as well. The ailerons look quite thin, and they're only made with this foam. But I'm going to try putting some, I've got some 3mm carbon rods, so I'm going to try putting some 3mm carbon rod in there and see what they're like. If not, probably what I'll do is I'll just make some out of some balsa, so that'll be all right for that. And the parts that are going to go in here, I've got two 9-gram metal geared servos. With flying wings, I'd always advise you to use metal gear servos. I've used the cheaper ones you can get from Hobby Kings and that, and they're all right. But if you do have a bit of a heavy landing, they don't tend to last very well. And I think some of them I found there is quite a lot of play in the actual nylon gears. So with flying wings now, I always use metal gear servos. So this is going to be the engine mount, and this is going to be back here a little bit. So within this section here, remembering the design, we cut it along there. So we're going to get some thin ply in there, cut this section back quite a bit, and then this engine mount, which I've 3D printed, that's going to slide on there and sit in there to bring the motor up. And the motor I'm going to use, I've just got one of the cheap and cheerful 2200 kV motors here. The cheapest chips these are, and I've used them on all my flying wings, and I think it'll be just right for this. If I can get my other flying wing, compare the size. So yeah, we're very similar in size there. So and this has got a 2200 kV motor on it, and these are absolutely brilliant, these motors. And so it'll be running a 6x4 prop. So I'm going to put a flight controller in this. I've got an Omnibus F4 flight controller with iNav. So I'm debating whether to put it in first of all, or just get it flying first and see what it's like. So that brings us to the end of the video, guys. Hope you found it useful, and it'll give you a good idea of how to use DevWing Foam. And I know it's not a free program, and it does cost a bit of money, but personally I think it's well worth the money, because I haven't found anything yet I can't do with it. and I still keep finding little bits and pieces in it. In the next video, part 4, what I'll do is I'll build the wing up. I won't video that much of it. I'll probably drop some pictures in, because I'm sure you guys that are watching this know how to build anyway. And then what we'll do is we'll take her for a maiden flight and see how she goes. So I'm probably going to put the INAV flight controller in as well. So once again, guys, thanks very much for watching. Please give us a thumbs up and subscribe, and I'll catch you in the next video.